Hi class, this is Neil, and this is lesson 2 on function notation. Okay, so the do now of this lesson is simply solving two different equations. In the first equation, we're told to solve for the variable a. And we're given the equation a plus 2 divided by 3 minus 4 equals 5. If you're stuck on where to start, one thing to think about is what operation on the left side of that equation is the farthest from a? And that's really that minus 4. So to undo subtraction by 4, we add 4 to both sides. And then we're left with a plus 2 divided by 3 equals 9. The next thing we'll want to undo is that division by 3, and we're going to do that by multiplying by 3. And I'll have a plus 2 equals 27. 3's are going to cancel there. 9 times 3 is 27. To solve for a then, I'm going to subtract 2 from both sides, and I'll have a equals 25. Okay, for question 2, what is the big difference you notice between question 1 and 2? Well, 2 has all letters, so it's a little bit different, but the method is going to be the same. Here we're going to solve for x in terms of a, b, and c. So this is actually called a literal equation because we're just dealing with letters here. The letter that we want to solve for, the variable we're solving for, is x. To get x by itself, the first thing I'm going to want to do is subtract b from both sides. Now, you should notice that c and b are not like terms, so I can't combine those. I just have to keep those as separate. So c minus b. And now I have a times x equals c minus b. To get x by itself, I'm going to divide both sides by a. And I'll have x equals c minus b divided by a. All right, the work on the second page is really connected to the activity we did in Desmos, so we won't spend much time on it. I mean, the important piece of information here, if you notice, Carrie has sketched out two function machines for us here. And the way a function works is it takes an input, it uses some sort of rule to create an output. Our rule in this first drawing, well, what is our input? We have a dirty shirt, some rule or something happens to it, and we're given an output. The rule here would be it's getting washed. I'm washing my shirt, or it's going through a washing machine. What do you think the rule is here? I'm not going to tell you. Okay, so let's look at our practice questions here. So in our practice, we're told a function, f of x, is given with example inputs and outputs specified below. So one thing to note is in each of these examples, we see the input and the output in a specific place. So in example 1, f of 4, 4 is our input. 20 is our output, and that f represents the function. In example 2, 7 is our input, 35 is our output. Example 3, the third part of the example, 2 is our input, 10 is our output. And for the last one, negative 3 is our input, negative 15 is our output. Okay, so what rule or what function do you think we're using to get from that input to that output? You're right if you said the rule is we're multiplying by 5. If I were to write that as a function rule, I would write f of x equals 5x. So our function is f of x equals 5x. All right, what will the output be for f of 8? Well, remember, our rule is that we're multiplying by 5. So if my input is 8, my output there would be 8 times 5, or 40. Now, if I were to use my function notation to write that, I would write f of 8 equals 5 times 8, which is 40. Okay, what will the output be for f of 10? Part B. So f of 10 equals, you're right if you said 50. If I use my function rule, 5 times 10 is 50. Okay, if the output of the function is negative 30, what was the input given to the function? Well, here we're given our output. So we're given what f of x is. What I don't know is what was my input. So I'm going to write that as an equation, negative 30 equals 5x. Now some of you are probably doing that in your head. Well, if I end up with negative 30 and I multiply by 5, and that's my rule to get negative 30, it would have to be negative 6. Mathematically, what we would do to solve this equation we just wrote is just divide by 5. Okay, and I'll get, x equals negative 6. Okay, what's the general equation for f of x? Oh, well, I did that at the beginning. I should have followed the route of the questions to get to this, but my rule here is f of x equals 5x. All right, so in this next example, or this next question, we're told a collection of inputs, x, and outputs, h of x, are collected in the table below. So we've got an input of 2, output of 3, input of 5, output of 9, input of 7, output of 13, input of negative 4, output of negative 9. That's a tough one. When I first look at this, I'm thinking, okay, 2 plus 1 is 3. That works. But 5 plus 1 doesn't give me 9. 7 plus 1 doesn't give me 13. So there has to be something else going on here. If I look at this pattern, I might ask myself, what can I do to 5? Let's use 5. To get close to 9. Well, if I do 5 times 2, that gives me 10. That's pretty close to 9. What do I have to do to 10 to get to 9? Well, I subtract 1. Okay, so my rule here would really be times 2 minus 1. Let's see if that works. Okay, let's try 7 times 2 is 14. 14 minus 1 is 13. That works. That looks like the rule. Okay, so first, what will the output be for the line of code h of 8? Okay, so my input is 8. So if I follow my rule, it would be 8 times 2, which is 16, minus 1 is 15. So my output should be 15. All right, if the output is 21, what was the input given to the function? Okay, so this time we got to kind of work backwards. All right, so 21 is what we end up with. We know we have to subtract 1 from something to give us 21. And we know that we have to multiply that something by 2. There's really two big questions here. Now I could either do this in my head, or what I could do is go ahead and write my general equation for h of x. So h of x here is the same as 2 times my input, or 2x minus 1. Okay, so using this general equation then, I'm going to say that 21 is equal to 2x minus 1. Okay, if I add 1 to both sides, I'm going to get 22 is equal to 2x. That's really messy. Sorry, guys. 2x equals 22. Divide by 2. Divide by 2. X equals 11. Okay, so there's my general equation. I guess what I could have done here is work backwards. Add 1 to 21 is 22. Divide by 2 is 11. I could have done that in my head, but it's late in the day and I wanted to just write my equation. Okay, so I believe the challenge was optional for today's work, and you didn't have to do the lesson portion. I could be wrong about that, but I think this was our goal for you guys for today. So I'm going to stop the video here. If I have to make a second video, I'll post it separately.